Let's get started with part 2 of Lab 7. And in this part, we're going to be drawing a cross section. Now, you've drawn a topographic profile before, which shows where the land surface is, the topography is, and how it changes as we go across a line. And now you're going to, once again, draw where the land surface is, but you're also going to draw where the water table is. And so you're going to have two different surfaces on this topographic profile. So here's the information that you're given. You're given a series of wells going A through K across this area here. And then this is your cross section here. It goes from 600 feet above sea level to 900 feet above sea level. And the first values are reported in this column here are the values of the land. So this should look similar to topographic profiles you've drawn in the past, except you don't have to work with a map. You're already given the map locations A through K of these different points here by these lines coming down to the cross section here. So one thing you'll do is you'll enter these values. So let's put some values on here. At A, it's each one of these squares here is 10 feet. So 890 would be located right here. 880 at B would be here. 870 at C would be one more square down here. 850 at D would be 5 down here. And 820 at E would be 2 up or 8 down. And you'll continue this all the way along, but once you get all those drawn in, remember the topographic profile is a nice, as smooth as you can draw it line that goes directly through all those points. It should go through that point. That's the surface here, right? That's where your house would be. That's where the trees would be. That's the surface of the earth here, the land surface. But the other line you're going to put in is the water table elevation. So all of these are water wells that have been drilled into the ground. They're currently not being pumped. So the level of water in each of these wells, the elevation, is going to tell us where the water table is. So I'm going to go ahead and change to a blue color here. And let's put in similar. So the first 1, 2, 3, 4 are all 780. So A, B, C, D, all 780. So 2 down from here, here, and here, and here. Not much change in the water table here. And at E, we go down just a little bit to 770. So the water table through this area here, oops, is pretty flat. And then here it starts to dip off just a little bit. So if we were drilling a water well at B, we would start drilling at the surface of the land here. This would all be underneath the ground. But if we tried to pump out of this area here, we would not be able to pump out of this area here until we get below this blue line here, right? This is the top of the water table, sometimes symbolized by a triangle. And that would be where we're able to pump water out of the ground beneath that. So you'll map out, or you'll make the rest of that profile there, and you'll answer some questions like, you'll label where the saturated and unsaturated zones are, or the aquifer and unsaturated zone. Also, a spring is anywhere where the water table is above the surface of the earth. So you should have one example on your cross section of where that happens. And then this part here reports that there's a change. Well C starts to be pumped, and the new, once it's starting to be pumped, the new water level in well C is at 620 feet. So if we go back to our cross section here, now instead of at well C at the water being at 780, now it's all the way down at 620 feet at well C. So it's down at this area here. And it also tells you at well A, things are unaffected. Put a little X on here. And at well E, things are unaffected. So you'll answer some questions, right? In the table, you're going to enter what the change in elevation was, and you could do that just by adding those, or by using that new number and this number in order to calculate it, or you could count the squares on your profile here and see what this distance is here, right? We give that a special name. And then you're also going to sketch in the cone of depression, because well, B and D went dry, but we don't know how deep those are, so we don't know where they're going dry, but we do know where water has been drawn out of the ground. It's been in this general area here. You'll sketch on a cone of depression in this area here, and then wherever that cone of depression, whatever elevation value it is below B and D, you will report that in the table here for the change in water table elevation at B and D.